When I was a kid, I always wondered how compressors worked. Well, there's two kinds of compressors, rotary compressors and piston compressors. You've got two examples right there. The rotary ones are almost always used in air conditioners, and in refrigerators they often use the piston style, but not always. Every compressor has to have a gas input and a gas output, or air input, output. The larger tube on a compressor is always the gas input, smaller one is the output. On these rotary compressors, this big bulbous thing is a place to store extra freon in the system, and it's also a muffler. There's some screens in there and some grids. They help quiet down the sucking sound these things make. On a piston style compressor, there's often two input lines. One is just like the fill tube where you filled the system up and pinched it off, or have a little screw-on Schrader valve to put the freon in. And the other one is actually the suction line, even though they're technically both suction lines, that sucks the return freon from the system. And the output tube is smaller again, like I mentioned. So I chopped each style up so you can see how they work. So you have the body, the base, the cap. That's where the output tube comes from. The electricity input. And that's attached by a little connector. Nowadays, rotary air conditioning compressors are used in almost every system because they use a little bit less energy, they cost a little bit less to make, they weigh less, and they're smaller, so they're better all the way around. So now we're looking at the bottom side of this compressor, down there, and we take off these screws I've already loosened to see what's inside. You'll see why it's called rotary. You have a precision machined hardened steel plate, and like a circle, and a spring loaded vane. You can see the spring there. When this thing moves around, it's on an eccentric, and the gap changes here, shoving freon out one hole and sucking freon or gas in through this hole. You can see the hole there in that side of that little cylinder. There, now you can even see it better. That's the intake, and the exhaust is that other little hole there which has a one-way valve on it. So freon can pass in that direction but not come back this way. And this side has no valve that connects to there. So when you rotate this, you'll see what happens. Very ingenious, and you can see that vane which almost acts like a piston ring, always keeping pressure against the side of that rotating cylinder, sealing everything. So the freon comes in here, goes around that big space. That big space gets moved around, as you see, and then the space starts to become smaller against the vane till it finally pushes it all out. That little one-way valve you see down there, very quiet and very simple. Although these things need extra large rubber mounts on their bases, they seem to buzz quite a bit. The little thing in the middle is the oil pump, and that sends oil up to the center of the machine. And the bearing that's in this cast iron housing. If you flip the machine over, it's just a typical induction electric motor, which means it has no brushes, counterweight, and the pressurized freon actually comes up through that hole, fills the whole top of the cavity with pressurized freon, and there's the top, and then it blows out the output. Very ingenious design. And there's that little cylinder that rotates around. Now the vane is popping out. And you can see the offset machining on the crankshaft. Now for your typical piston style compressor that's been around since the dawn of compressors. They all have a motor that sits on 3 or 4 springs on the bottom. When you shake a compressor, you can hear it make clunking sounds. Well, that's this whole body bouncing around inside, and these castings hitting the body that holds the compressor unit. And the lid just reminds me of a cranium. Or a bell. Anyways, that's the bottom. If you look right down that little hole, the crankshaft is hollow, and there's a spiral of just sheet metal in there. And the spiral sits in the oil in the bottom, and actually the oil's usually an inch or 2 deep. And when it's spinning, it screws the oil up, because it sits like that, and the oil comes all the way up out the hole at the top of the crankshaft. The crankshaft looks a lot like a car crankshaft. It's made of cast iron like a car. It's got a counterweight on it. But the connecting rod to the crankshaft is quite different. It's very ingenious, long-lasting and quiet. This wiggly tube is the output. That's the compressor head and valve body. There's hardened steel flapper valves in there that just work like reed valves in a 2-stroke. Power comes in through here, and that just plugs into the pins on the inside of the body. This assembly here is the air intake, or freon intake, which is a gas. It's like a muffler too, and an oil separator. It sort of reduces the sucking sound, which can sound very annoying, separates the oil, then the oil dribbles out this little tiny hole, goes back into the bottom of the motor cavity. This part here is the piston. I'll show you what I mean. When you rotate the crankshaft, you can see the counterweight spinning around just like an engine. The ingenious design of the connecting rod. Oil would be just flowing out here, splashing everything and getting the piston wet. And you can see the piston going up and down in the cylinder. Simple and sweet. And the output pressure comes out through here, and that's a tiny muffler and filter too. And that did attach to there, which comes out that smaller tube I previously mentioned. And this is all made of cast iron, just like a real car engine. So I've just removed the cylinder head. You can see the cylinder, the piston. When I rotate the crankshaft, piston's going up and down. Exactly like any engine, made of the same materials too. There's the cylinder head and the 2 parts of the valve assembly. There's one reed valve, which is just a springy flap of metal, just like a 2-stroke. And there's the other one. So it just moves by air pressure against a hole in a machine plate. One for input and one for output. Simple as that. Now if you have an air compressor in your repair shop like I do to run all your air tools or your blower, or your paint gun or whatever, it might look like this. It's got 2 cylinders and a cylinder head. That's the filter for the air intake, and it also acts as a muffler. Crankcase with a crankshaft in the bottom. And air output. And its valves and everything work exactly the same way as this little fridge compressor. So if you ever want to take one up, it's pretty simple. There's no springs or anything. You just remove the head. Sometimes these little springy valve things snap off, and that's why your compressor seems to run fine, but it doesn't work anymore. There's also the diaphragm type compressors, which is just a big rubber thing going up and down over a cavity, but with the same kind of cylinder head like this. The rubber style compressors or diaphragm compressors are called oilless compressors, because they don't use oil. These fridge compressors and air conditioner compressors can be used for jobs, around the shop. The only disadvantage to them is they don't want to restart if you have a container that's already filled up with compressed air, like your storage container. They only like to restart when the pressures drop very low. That's the problem. If you're into doing airbrush artwork and any kind of smaller type of painting jobs, they work excellent for that, especially for airbrushes. All you have to do is add a little bleed off valve on the output line of the compressor to control the amount of air pressure coming to your little spray gun by bleeding some off. They do a great job. If you're into having fish in big tanks and stuff like that, they make a nice quiet and efficient bubbler. They can run all the time and just keep bubbling air into your water. People even use them to aerate ponds to keep trout and stuff in, because trout like a lot more oxygen. That's why they hang out in rapids. If you're using them for any purpose like that, just make sure you always have them in upright position, because the oil pump always sucks from the bottom. So if they're not upright, they soon seize up. These little compressors suffer all the same problems that a car engine does, except for the electric motor part can burn out. But you can have broken connecting rod, broken crankshaft, bad rings, seized piston, broken valves, all the same stuff. Very interesting, but nothing new. It's unfortunate they're made of such thick metal and so hard to cut open. I use my famous handy dandy cutting wheel that goes on my hand grinder, but those wheels are almost $5 a piece, and I went to 1.5 wheels to cut up these 2 units, because they have actually about 2 or more pounds of copper in each one. That one might have 3 pounds of copper, maybe that one does too, and these are just little ones. That one came from a 5 cubic foot apartment size freezer, and this came from a 6,000 BTU air conditioner. So those are some of the smaller ones. If you had a fast way of cutting these open and getting the copper out, you could get a good buck for them, for scrap anyways. So if you're a hobbyist like me, and you even want a compressor you can use in your home that isn't going to keep everybody awake and annoy them with the noise, these are very handy. Great for blowing out the dust from computers, from electronics, for your airbrush, for small painting jobs. You know, you can use a propane tank or a Freon bottle or something like that to make a reservoir for compressed air. And the air conditioner ones, they put out about 300 psi on the output. And the ones for refrigerators put out about 150 psi. Not bad. Very usable pressure for most jobs. Like, you can take a car apart with one. A compressor and a refrigerator or a freezer are exactly the same. The bigger they are, the more power they have, or the more cubic feet per minute they'll put out, but the pressures are always the same. If it runs on R12 gas or R134A gas, it puts out 150 psi. If it's from an air conditioner and it runs on R22 gas, it doesn't matter how big or powerful your air conditioner is, it puts out 300 psi. So just choose your size of your compressor, since they're so readily available today in scrap appliances and stuff, for your application. Simple as that.